balancing equation worksheet. This is from your lecture notes or lecture handouts. Let's complete a few of these. So before we start the problems or the balancing equations, let's look at the rule. So the first is you need to find whether the equation is balanced or not. If it's already balanced, you do not need to balance. And you're going to always use coefficient to balance. You're not going to change the subscript. Now, this is the balancing order. First, you're going to balance the elements that appear in the fewest numbers of molecules. After you are done with that, then you're going to balance the polyatomic ions as one unit, okay? And that too, you're going to balance polyatomic ion as a unit only if it is present on either side of the equation. That means, so if like KOH is present over here and there is another molecule over here, say, and then there is another molecule and this is BaOH2. So if it is present as this on both sides, then only you are going to balance it as a unit. But if it's not present as a polyatomic ion, then you're going to separate the polyatomic ion into oxygen and hydrogen atoms. So that is what you're going to do. Now, the next one is if an atom occurs as a free, like nitrogen or oxygen or zinc as a free, then that one you're going to balance at the end, because when you balance this, you put coefficient, then it is just going to affect the oxygen. It's not going to affect any other atoms. But if you put 2 over here, it's going to affect, in this potassium hydroxide, it affects potassium, it affects oxygen, it affects hydrogen. That's why we're going to balance this only at the end. And once all is done, you always need to count whether it is balanced or not. So now let's move on to our worksheet. So let's do number 3. Number 2 has polyatomic ion. So we're going to do it a little bit later. First, do the easy one. And what I do is whenever you are balancing, just write the reactant over here and product over here, and just write the number of, how many number of atoms are there for each element. So potassium, potassium, boron, boron, and oxygen, and oxygen. So on the reactant side, we have 1, on the product 2. It's 2 over here on the reactant side, and on the product side, we have just 1. When you look at the oxygen, we have 3 over here, and on the product side, we have 1. Okay, so first we're going to balance. We're not going to balance potassium or boron now because they are free elements. So we're going to balance first the oxygen in this case. There are 3 oxygen atoms on the reactant side and 1 on the product side. So what we need to do is, to make it equal, we need 3 oxygen atoms. So that means we need to multiply that by 3. If you multiply that by 3, then it is also going to affect the potassium. So this will also get multiplied by 3. So then we'll have 6 of those and 3 of those. So let's write that down. Let's put 3 over here. So now after we are done with that, now we can move on to either potassium or boron. So why don't we move on to the potassium? Because when we put 3 over here, it affected potassium. Now we have how many? 6 potassium atoms on the product side. So to make this 6, what we need to do is going to multiply this by 6. now we have how many? 6 potassium. So we have 6 over here, 6 over here, and oxygen 3 and 3. Now the only thing left over here is to balance boron atom. So there are 2 boron atoms on the left side. So to make this 2 atoms, you simply multiply that by 2. So just put 2 coefficient in front of it. Now let's look at it. We have 6, 2 and 3, 6, 2 and 3. And that means this equation is balanced. Let's move on to the next one. So let's do number 2. So again, let's write reactant and the product. There are hydrogen, and this is a polyatomic ion. This is a polyatomic ion. This is a polyatomic ion. So because we have OH here as a polyatomic ion, what we do is we will think H2O as HOH. Okay, so I'm going to write it over here, and this will make us easier to balance the reaction. If this OH was not here, then we do not do it this way. But because there is a polyatomic ion here, so that is why we also change it to hydrogen and hydroxide. Okay, so we have how many hydrogens? 3, and then phosphate ions, how many? Just 1. And potassium, we have 1. And hydroxide, we have 1. So moving to the other side, how many hydrogens we have? Do not look at these. There are 2 here, but if you look at this form, there is just 1. And phosphate, we have 1 phosphate. And potassium, how many do we have? We have 3 potassium. And hydroxide ion, we have just 1 hydroxide ion. Okay, so now let's start our work. So first, we're going to balance the elements that appear in the fewest numbers of molecules, which means we can either start with hydrogen or start with potassium. So we're going to start with hydrogen. We have 3 hydrogen atoms over here, and there is just 1 hydrogen atom. So to make this 3, we will multiply this by 3. And when you multiply this by 3, it is not going to only affect this hydrogen, it also affects the hydroxide, which means this is also multiplied by 3. So we have 3 hydrogen atoms and then 3 hydroxide ions. So that's done. Now, the next step is to move on to the potassium. How many potassiums are there? There is 1 over here and there are 3 over here. So what we're going to do is we're going to multiply this potassium by 3 so that we have 3 potassiums on both sides, okay? And what it did over here is it also affected hydroxide ion. So this also got multiplied. Now look over here, we have this and this equal, hydroxide and hydroxide ion equal, hydrogen and hydrogen equal. And the last one, what we need to balance is the phosphate ion. And we have 1 phosphate over here, and then the 1 phosphate on the other side. So that means our work is done. Our equation is balanced. So the last thing what you need to do is, instead of putting this 3 over here, you need to bring this 3 down and put it back over there. And now you can, the work of this hydrogen hydroxide is done. So you can simply erase that. So now let's do number 18. This is the reactant side and that's the product side. So reactant side, we have 1, 2 rubidium atoms. And because nitrate as a polyatomic ion is present over here, but it is not in the form of polyatomic ion, so we are not going to look at it as a polyatomic ion. We're going to separate those two atoms. So 1 atom of nitrogen and 3 atoms of oxygen. And again, on the product side, we have 2 atoms of rubidium, 2 nitrogen atoms, and 1 oxygen atoms. So we're going to first fix these one. These 2 are in free form. We're going to do it at the end. So because the rubidium is balanced, we're not going to touch the rubidium. We're going to first balance the oxygen. There are 3 here and there is 1 here, which means if we multiply by 3, then it will be 3 over here and 3 over there. But this also affected rubidium, and we're going to do this later, deal about this later. So now let's look at the number of nitrogens. There are 2 here, so we need to make this also 2. So multiply that by 2. It became 2 now. So 2 nitrogen and 2 nitrogen over here. So when this was multiplied by 2, this not only affected the nitrogen, but it also affected the oxygen, because now we have 6 oxygen atoms. So in order to balance the oxygen atoms on either side, we need to multiply that by 2, which means instead of 3, we need to multiply that by 6. So instead of 3, we multiplied that by 6, and now we have 6 oxygen atoms. So let's write this down over here. These are balanced, and looks like the nitrogen is also balanced. So nitrogen is balanced on either side. Oxygen is balanced on either side. Now we need to balance the rubidium, because we multiplied again this. So now we have 12 rubidium atoms on this side. So we need to make this 12. So in order to make that 12, we have 2 over here, and then we have 1 separate, right? So we can just multiply this by 10. Then it's going to be 12 on this side and 12 on that side. So then that means we will have 12 over here and then 12 over here. And it looks like all of the atoms are now balanced. So let's clear this out, and I am sure you can do the rest.